All right, welcome to Composite Area Level 3. Now, in this one, we're going to tackle a problem that I would say is just a little bit time consuming, but relatively simple once you understand two big ideas. And what are our two big ideas? Well, they're going to be this first idea that whenever we have the total segment and multiple pieces that we know, we can always subtract away the pieces that we know to find the pieces that we don't know. And then also this idea of semicircles. But let's go ahead and start breaking this shape down piece by piece. Now, we want to start by breaking this down, and I would actually use vertical lines here rather than horizontal lines because I believe that this would actually be a little bit easier. And we see that we have 1, 2, 3, 4 rectangles and a semicircle that we're going to have to find the area of each of these things. Now, let's go ahead and get started with our first rectangle, and I'll still keep blue for this one. And this one's the easiest of all because we actually know its base and we know its height. We can go ahead and start finding its area. So let's write this. We'll write the area of our rectangle. And let's see. We know that it's always going to be the base times the height. And in this case, our base will be 3.2 times our height of 17. And this will equal, and of course, you probably have to grab your calculator at this point. So 3.2 times 17 gives us 54.4. And it's in inches, so of course we could write inches squared. All right. Now, this will bring us to that first idea of whenever we know the total of something and we're having to take away a segment. So, I'm going to block off this in this kind of this UT burnt orange. And this will be the next thing that we want to find. Now, we're fortunate. We know its base is 4.6, but what we don't know is we don't know the height. And so what I see is I see that this entire line is 17, and I see that this piece is 9. So if I want to find this missing piece right here, I'll simply take my total, 17, minus my piece, 9, and we know that 17 minus 9, of course, would give us 8. So now I know, okay, you know what? That is 8 units tall. So we'll come back over here, and we'll now find the area of our kind of this UT burnt orange rectangle. So let's see, we know that's still going to be base times height. And we know that in our case, our base is 4.6 times. We know the height, that's that number we discovered, was 8. And so when I multiply these two numbers together, let's see, 4.6 times 8, we're going to get 36.8. In this case, that would still be inches squared. And if you want, we can go ahead and we can write, hey, this was 54.4, and we can write this in here, this 36.8. I know it's a little cramped, so I don't know if I'll be able to do this all the way, but yeah, so we know that area, and we know that area. Okay, well, let's move on to our next one, and let's go to this nice little magenta. So now we want to find the area of this rectangle. Now this one's actually a little bit different. Notice how this one was 8 units long, so then this line right here must be 8 units long. And if this line is 8 and this line is 5, well, in this case, we don't know the whole thing, we know 2 of the pieces. And so when we know the 2 pieces, instead of subtracting, what do you think we should do? Of course, we should add them together. And so it turns out that for this magenta rectangle, well, we know, of course, it's still base times height, where our base was 3.1 times. And in this case, our height, we know that it was 5 and 8, and so 5 plus 8, of course, will give us 13. So we have 3.1 times 13. Let's go ahead and multiply that. 3.1 times 13, and that will give us 40.3. 40.3 inches squared. And, if you'd like, you can write it in 40.3. I'll scribble out that 8 so we're not confused with that. Okay, well, moving on over, now we have this very last rectangle. And I think this is where people struggle the most. So let me go ahead and switch to this red. And when we look at this, well, we know its height is 6. So, I could even start right here, say area of a rectangle. It's the base times the height. In this case, we don't know our base yet, but we do know the height is going to be 6. They do give us that. Very nice of them. Now, we look, and we actually know this length right here. We know this length, and we know this length. Well, we know 3 lengths out of the entire 15. And so what we want to do in this case is we simply want to do 15, this total length, minus, I can put a parentheses right here, minus 3.1, plus, because I'm going to combine these 3 lengths, 4.6, oh, shouldn't have ended that, plus 3.2. In fact, here, let me undo that. Okay, 4.6 plus 3.2. Once again, I'm getting that length from here, here, and here. I'm adding all those together, and I'm subtracting, they're all the pieces, I'm subtracting them away from 15. And so when we do this, let me go to my calculator here. When we do 15 minus 3.1 and 4.6 and 3.2, we get that this leftover length is equal to 4.1. And so now we know, hey, that is 4.1 inches right there. Well, we knew the height was 6. Now we know the base is 4.1. And if we were to do 6 times 4.1, well, of course, that's going to give us 24.6 inches squared. All right. I would try and fit that in, but I don't think that would work out well. Well, let's go ahead and kind of running out colors that I typically use here. Let's go ahead and switch this kind of lime green. That only leaves us this semicircle. And we actually know the diameter of that semicircle is 6. Well, thinking about our previous examples, if we know the diameter is 6, then our radius, which always goes from the center to the edge, will be half of that. And what's half of 6? Well, of course, that would be 3. And so in this case, let's just go ahead and work that out right here. I'll kind of give myself a little dedicated area. And so we know that the area of a circle is pi r squared. In this case, that would be pi 3 squared. And we know that, let's see, we know that 3 squared is 9. So you could actually think of this as 9 pi. All I did here was just flip-flop the 2. But once again, it's a semicircle. It's half a circle. And because it's half a circle, we're going to have to take half of the area. So let's see. And of course, I think we know by now that would give us 4.5 pi. Well, if you want that decimal, all you have to do is 4.5 times pi, and that will give us 14.14. And still inches squared. Well, I know this seems like a lot, but we're one step away. We know that our very first area was 54.4, our second area was 36.8, our third area was 40.3, our fourth area was 24.6, and our fifth area was 14.14, and now we just want to take these 5 numbers and add them up. So 54.4 plus 36.8 plus 40.3 plus 24.6 plus 14.14, and that will give us 170.24. So I'll go ahead and write that down. That's 170.24 inches squared. And that is our total area when we add up all 5 of these shapes. All right, I hope that helps, and good luck.